I'll remember to click the magic button and take attendance. So tell me that you're here, please. And then we shall begin. Today is a Python day, so open up idle, please. Reinstall it if it got uninstalled. No worries. But we will be doing Python today. It's all about conditionals and shapes. So learning how to do if in Python now, just like we were doing in Scratch. And then how to draw cooler shapes, because why not? Okay? So that's the goal for the day. Let's start with conditionals. Conditionals in Python. And it looks like I can make this slightly larger for y'all. There we go. Conditionals in Python. So this is the direct equivalent of the if-else kind of block from Scratch. So that's what we're going to figure out how to do in Python. So like we had this, and it had the else part, and then this was like the if part. From Scratch, it was like if some big long conditional expression, something that became true or false, right? That was important. It was a different shape for different kinds of things that could only become true or false. So if that is true, then we do the then part. Otherwise, there was an else here, and we did like the else part. So if this is true, then we do this thing, everything that we put right here. Otherwise, else, we do everything down here. So otherwise, I guess. Otherwise, we do everything in the else case. Okay, so if condition is true, then do all this stuff. Otherwise, do all this stuff. That's the Scratch if block, if else block all over again. So let's make that happen in Python now. Okay, so to get there, we need to talk about like this fancy shape that we're stealing from Scratch. That is something that could only ever become true or false, right? Because it needs to direct that block to do one thing or the other. So true or false is what we need here. It's called a Boolean, okay? And that brings us to a new type in Python called bool. So just like we had ints were clouds, floats were clouds, now I have the bool cloud. And there's only two things that are bools. True with a capital T and false with a capital F. Okay? That's it. And that's going to allow us, this idea is going to allow us to control things. So remember the other clouds, like int had like a million, infinite numbers of things, right? 0, 42, negative 42. Bool just has true and false. That's it. That's the entire cloud. And that's the type. So what is the type of true? It is a bool. Same with false. Remember the capitals. So yeah, just like in Scratch, we can use true or false to control the way that a program executes. So we can ask things like, maybe we have a variable called n and it holds some value, like 5 or 42 or something special. We can ask in Python the kinds of questions that we've been asking in Scratch. So like, hey, is n less than 7? That's a true or false question, right? If the answer is yes, then we know that that answer was true and we can do something with that. Otherwise, we can do something else. We can ask more questions, a bunch of if statements, if blocks. Is n like less than 3? Oh, that one's not true, right? Right? The answer for that would be no, and in Python that is false. Okay? So the answers to these questions, instead of yes or no, we say capital true and capital false. That's what Python is doing. And that will let us control stuff. Do one thing if the result of your expression that becomes true or false is true, or do the other thing if it's false. So like this is kind of how our programs are going to look now. Hey, is n less than 7? If it's true, do all this stuff. Otherwise, if it's false, do all this stuff. That's the goal. Okay? And yeah, Booleans, the bool type allows our code to branch. It's quite nice. And it is just a normal type. Like I could assign a Boolean to a variable, like b equals true. That's totally fine. That's not a problem. And that just makes a b variable that holds true. Because why not? What is B? B is true. Type of B, still a bool. Yeah, it's just a new type of things holding true or false. That's all we need to say one thing or the other, to say yes or no. Any questions about this? We're giving a name to things that could be true or false, calling them bools. All right, let's keep trucking then. So, how do we make bools? Instead of just typing straight true and straight false, what happens? What if we want to do something more involved, right? So let's talk about how to make Boolean expressions. That is just a fancy word for any code that becomes true. It results in true or false, okay? That is the idea. So we can ask things about like existing variables, like, hey, is x greater than y, for example? We can ask that if we have an x laying around. Maybe it's 10, and we have a y laying around. Maybe it's 5. We can ask in Python, hey, is x greater than y? Okay? That is a symbol. That causes Python to check, hey, look at x, look at y, see which one's bigger. Hey, is x bigger? X is 10, y is 5. Hey, is x greater than y? Yeah, it's true. It goes in and executes that. It figures it out. The answer is yes. So it gives back true. And if you do the opposite, hey, is y greater than x? That's, of course, false, right? Because y was smaller. So these are the kinds of things we can ask Python to do. We can ask it to compare things, okay? So you have your greater than symbol. You have your less than symbol. It's very hard to type this character in a computer. So we just type a less than and an equal to, or a greater than and an equal to right after it, okay? So like, hey, is 2 greater than or equal to 2? Yes, but it's not strictly greater than 2. Yeah, those are the operations, the operators. Any questions about those? So it's just text that causes Python to compare things. If you want to check if things are equal, you use 2 equal signs, because remember we already are doing something with a single equal sign, that is assigning a value to a variable. So we need another way of checking for equality. Hey, is 5 equal to 5? You need 2 equal signs so that Python doesn't get confused and think you're trying to give a value to a variable. Okay, so it's double equals to check for equality, to test it. So yeah, 5 is equal to 5, but hey, is 5 equal to 3? No, that's false. Okay, so Python knows how to check all these things. If you want to check if things are not equal to one another, there's also a symbol for that. You have an exclamation point and an equal sign. Checks for disequality. Okay. That's something interesting. So just read the exclamation point as not. Hey, is 5 not equal to 3 maybe? Yeah, that's a true statement, right? 5 is not equal to 3. That is true. Is 5 not equal to 5? No, of course not. It's equal, so it's false. It is not unequal. Yeah, that's kind of weird to wrap your mind around, but hopefully that makes enough sense. Any questions about those symbols? Just how we get Python to look at things and give back a yes or no answer, okay? So, if we're still happy, we want to combine things as well. Like, hey, I want to check if this is true and this is true, or this is true or this is true. In Python, you just write out the words and, or, and not. Those do those operators that we know already, right? And that combines 2 Boolean values, doesn't it? Combines 2 Boolean values into another Boolean, just like our truth tables tell us how. So you can check for things like, hey, maybe you're making a program for some reason that checks if somebody waiting in line to ride an amusement park ride is able to ride it. So you'd be checking things like, hey, is your age greater than 12 and is your height in inches like greater than 48 or something? Yeah. You can combine 2 Boolean values, because this left side will be a bool, this right side will be a bool. You can combine them using an AND operator, okay? You just write out the word AND. It works out just fine. So remember your truth table for all those things, because those are going to come in handy again. So X AND with Y, true, 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 false, false, true, false, false. Sorry, this is so small. But the only time they're true, the AND is true is when they're both true, right? So that's the goal. So that's the kind of thing we would like to do. Hey, is 5 less than 10 and is 3 less than 11. Those are both true, so they're combined, their AND result together will also be true. Okay? Any questions about that? Does that make enough sense? But if one side is false, like hey is 3 greater than 11, of course their combined condition is false. ANDing together true with false is false. But their OR is true. I can OR those together. As long as one side is true with an OR, the whole thing will be true. Hey, is 5 less than 10 or is 3 greater than 11? Yeah, one of those was true. At least one was true. Okay? So that is Boolean expressions. Building up big things. And not also works as well. You can negate something like the not of true is false, the not of false is true, all that kind of stuff. Yeah? Any questions about these ideas before I give you a question on them? All right, so definitely remember that double equals to check for equality, because you'll run into trouble later if you use a single equals accidentally. It's not the same, right? It sets a variable, whereas this actually compares and gives back true or false. The first checks for equality, and the second sets a variable to a value that you pass along. It happens, especially as you're starting out, to accidentally use this one. Don't worry, you'll get an error. In theory, it'll be okay. So the next thing that I like to do is test you on whether or not you understood what I just said. So get into peer instruction groups, please, and we're going to do a by-clicker question. So which of these are your 4 options of Python code, which comparison is true when you have an x variable, you're not sure what it holds, but you want to test whether it holds one of these blue numbers, like x is between this range or it's between like this range, right? It's one of those. So it's either here, like x is within this, or it's also within this, okay? If x is 4, 5, 6, 7, 8, or 13, 14, and 15, yeah? That's what we would like to check. So which of these comparisons, which of these expressions that result in true or false, gives back true exactly when x is in one of these, and false otherwise? Does everybody understand the question? How do you check if x is one of those blue values? Okay, so take a little while, try that out, and let me start the question over here so you can just answer it when you're ready. But take a couple minutes, discuss as a group what you think the answer should be, and then we will talk about it. This is an important pattern. You will check things like this forever. Which should it be? Got a few responses. I'll give you 30 more seconds to get something in. All right, is that enough time to get something in? Drum roll, please. All right, look at us. We are with a majority saying D. Let's see. So why is it not A? D is the right answer. Why is it not A? Yeah, if x is greater than 4, that's like saying, all right, it's true when all, like, the number is this way, right? So it's like coloring all of these in, and then we have to somehow exclude others, right? So then also x better be less than or equal to 15. So it does this. It takes all of those numbers, including these ones. See that? Don't want that. What about B? Why does B not work? X greater than 4 and x less than 8. Or x greater than 13 and x less than 15. Well, this one, if we just look at this, what's it looking for? When is it true? When x is greater than 4, strictly greater than, so we just skipped 4, and x is less than 8, strictly less than, so it just skipped 8. See that? The other one is same with it. X is strictly greater than 13, so it skipped it. X is strictly smaller than 15, so it skipped it. That's not good enough, right? We're missing things. And then C, x greater than or equal to 4, that's fine. Then strictly less than 8, oh man, we missed the 8 again. And then this one's fine. X is greater than 12, yeah, that'll take 13 onwards. X is less than 16, that's fine. But we missed the 8. And then the last one works because strictly greater than 3 gets the 4. Less than or equal to 8 keeps the 8. So that's true. Or this is true. X is greater than or equal to 13. And it's strictly less than 16. So from 15 downwards. Okay? Any questions about that? Seems like we got it. All right. So, yeah, I think we're ready to, like, write real code. Let me make just a quick file to give to you to talk about some of these things that I just wrote here on the REPL. What day are we in? So where is my desktop? There it is. Are we in lecture 17? Let's find out. Yeah, we are. Okay, so lecture 17. Let's make a folder for that. So I'll do like bools.py, just really quickly, being like, print the type of true, all that stuff that I just showed you, just very quickly. And B is true, print not B, things like that. Just showing that you can do stuff with Python. Print, I don't know, hey, is 3 equal to 3? Hey, is 3 not equal to 3? So when you look at this later, it might make a little bit of sense, because I can't give you what I wrote on the REPL. All right, stuff that we talked about. That all makes sense, I hope. Now, we're ready for if statements, okay? We'll also do it. So, instead of blocks in textual code, it's called a statement, okay? It's called an if statement instead of an if block. That's what we'll write in Python. And what it does is it tests a condition, right? So it looks like this. You say the word if, and then you give your condition, whatever it should be, something that's going to become true or false. We know how to do a bunch of those now with our operators and combinators. And then after the condition, you give a colon, and then you tab over. You have some spaces or a tab, doesn't matter, as long as there's some offset between the if part and the part that you want to be executed when it gets true. Just like a tab. Python will do it automatically for you. And then this is where you put all the code that you want to be executed when the condition is true. Code to execute. And you stay on that indentation line for as long as you need to. When cond is true. Okay, so if that condition is true, any indented code gets executed. That is an if statement. And then you like tab back out. You go back to the original top level, And then the regular code that you want to just have after the if goes down here. Regular code here is always executed. Okay, so this is the part. It's testing something, testing the condition, and doing stuff if it's true. Okay, as many lines as you want. And then once you're done with the if, you just put normal regular code down below it, unindented, and that code always gets executed just like anything else. Okay, so after the indentation, I guess, is finished, or if the condition was false, the program continues with the unindented code. Okay, so let me show this to you. I guess maybe I'll make a new, just a big file called conditionals.py. So here's what I was trying to say. It's not helpful that I can't get my start menu right now. There. So here is, I don't know, x is 42 or something. And then let's do something if x is greater than 10. If x is greater than 10, colon, let's print something like x is greater than 10, sure. And then you can do more stuff up here. It's like, all right, x equals x plus 1, print x. Do as many things as you need to do, but indented. And then you can unindent yourself and go down here. Print this line always gets executed. Print, I don't know, 2 plus 2. So does this one. Okay? So this is a condition. This is an if statement. Okay? This is our first if statement. It checks this condition. If it's true, it'll run this code. If it's false, it won't. And then this code is unindented, so it's always just like normal. It's as if it were like up here or something. It's going to run always. Okay? So, is it going to hit this condition? Like, is it true? Is it going to work? Is it going to print all the print lines? Yeah, because x was 42. That means, yeah, it was greater than 10. It was true. And so it's going to make x 43. It's going to run all these lines in the if statement and print x. And then it's going to finish the if. Now it's done with this whole darn thing. Go back to the unindented code and just always run it as usual, like every other program we've written. So this line always gets executed and for. Okay? Any questions about what just happened here? That's an if statement. Yeah.
Simple question. I don't know if it's like a style thing or like preference, but when you have your conditional, you can either surround it with parentheses or not. Like I noticed in your slideshow, they're all surrounded by parentheses. Does it matter? Like, do you think it really matters if we surround it with parentheses or
No,
not?
in Python it does not matter. In other languages like C++ and Java and things, you are forced to use parentheses, and so that's why people probably still use them when they're writing Python. But yeah, it doesn't hurt you to write parentheses here, but as far as I know, I think it is incorrect style.
Okay.
I think it is, because you can do it this way, you should do it this way. That's as much as I've seen, at least. Good question. Any other questions? But yeah, you can always add as many parentheses as you want anyway, right? That's not a problem. All right. So let's make x 7 and watch what happens. Oh, this never gets run, right? Because x is not greater than 10. If this is true, it would run these lines, but it isn't now because I made x 7 instead. And so now back down here, we just do the rest of this code. We skip this whole thing and run this normal straight line code down here. Okay, does everybody understand what's happening now when it was a false condition? It didn't run the code. All right, so let me section this off because now I have more things to talk about. Let's keep going. Let's talk about if-else statements now, okay? So we like our if-else block as well in if-then-else, maybe. We like that block in Scratch, so let's have that here too. Sometimes it's nice to do something if an expression is true, one thing, or if it's false, another thing, right? So, what we'd like to do is this. We'd like to have a condition that gets checked. If it's true, we do one thing, we do the true stuff. If it's false, we do another thing, we do the false stuff. And only one of those ever gets run based on the condition. And then once we're done with that, we can go back down, like unindent ourselves and go and run the rest of our straight line code. Okay, so that's the kind of thing we'd like to do. And the way you can do it in Python is with if-else. So still keep your if cond is true, do your true stuff after tabbing in true stuff. And then you unindent and you say else, colon. This is called an if-else statement. Else, colon. Then you tab over again and do your false stuff. Okay? So yeah, if the condition is true, then the true cases, we call it the body right here. We call this the body of the true case, the if statement. That is run. Otherwise, it's the body of the false case that gets run. All the indented stuff. Okay? And then everything after it always gets run after you unindent again and start writing code. Okay? So that's an if-else statement. It's either run the true body or the false body, the if branch or the false branch. All right, true branch or false branch. Many different words for the same thing. So let's try this. So if x is greater than 10, let's do something. Print x is greater than 10. Else print x is not greater than 10. Yeah? All right, let's do something different. Let's use y instead. Y equals, we can keep it 7 right now. I'll show you both ways. Y. So this is the indented part. There's just a single line. This is the indented part. There's just a single line. And this is unindented, so it's just normal code again. Okay? So Python is going to set y to 7, and it's going to then run the whole if-else. Right? That's one big chunk as far as it's concerned. So it checks the condition, and it decides, hey, am I going to run this body or this body? And then after it's done all that, it's like this whole thing is over with, and it runs the rest of the code. Okay? So what will it print now? Drum roll, please. Y is not greater than 10, right? Because y is 7. So it goes straight to the else case, and it skips the if. I can do the opposite, right? If I make y 11, now it is greater than 10. And so we went to that branch. Y is greater than 10. It prints this one, skips the else case, right? It's only one or the other. If it's true, do one thing. If it's false, do the other thing. Okay? And this line is always executed, as usual. Any questions about that code? That's kind of cool. Kind of useful. Are we ready for the biggest thing? There's still one more kind of statement that I haven't shown you yet in terms of if and else. There's more to go. Are we comfortable with these? Just a single if to do something if something's true and nothing otherwise? And if else to do one thing if it's true, another thing if it's false? Because there is a third option. Whee. Are you ready for it? All right. It's called elif, if, elif, else statements. Okay? So this is technically unnecessary. You don't lose, you don't gain any power, any expressive power by adding this thing called elif, but it makes your programs look a lot nicer. Okay? So let's talk about it. This is for when your conditions get super duper messy and you need a bunch of if-elses that like are nested, and I'll try both ways. I'll show you. Maybe I'll make a new file for this actually. But a very standard example for this is grade calculation. So we'll ask the user to type in their grade, and then we'll give them just like a simplified version of a grade that is like either A, C, or F maybe. Just something simple with more than 2 options. And then I'll show you how to do it with normal if-else, and then I'll show you how to do it with if-elif-else. And I think you'll prefer the elif way. Okay? So, yeah, here's kind of the program that we want to write. Like, hey, is the grade greater than or equal to 90? If so, it was an A. Or, hey, was the grade greater than or equal to 70? If so, it was a C. And then otherwise, it was an F. Yeah? So that's kind of the program that we would like to write. And based on what we know, we could do that with if-else statements. We could first check, hey, did the grade that the user typed, was that greater than or equal to 90? Such a long phrase. If it's true, then we'll say A. We'll print A. If it's false, then we have more work to do. We're not sure if it's C or F yet. We have to test again. Is it greater than or equal to 70? If that's true, then it's a C. Otherwise, if that's false, then it must have been an F. Yeah? You see how there's like an if-else within an if-else going on there? So let me do that for you. Let me show you this code, and then I'll show you the elif way. I'll make a new file. Oops. We'll call this, I don't know, elif.py. So let's get a grade from the user, being like grade equals input, enter your grade or something, colon space. And then the user is going to type some number, and we want it to be able to be compared as a number. It may have decimal places, so it's not an int, it's a float. Okay, so I'll convert it to a float from a string. And then now I have a grade variable to work with that I got from the user. Let's do it this way. Let's check for what grade it was and print out the grade. So if, I'll just follow this little flowchart diagram, the first thing that I need to do is check if the grade is greater than or equal to 90. So if grade greater than or equal to 90, 90.0 if you want to be precise, saying that, yeah, it could be a decimal number. Doesn't matter though. Then print A, right? Otherwise, it could be a C or F. We're not sure which yet. We have to figure that out. So that's this guy, this little sub-expression down here. That is now what we need to check. So the first thing is, well, if, let's check if it's greater than or equal to 70. Grade greater than or equal to 70. If it's true, then it was a C, right? Print C. Otherwise, print F. Yeah? So it's like in this else case, we have to have another if-else. Lots of indentation. So enter your grade, 95, it's an A. If I rerun it, enter your grade, 75. We hit the else case and we tried it, and we got to this one, print C. Otherwise, enter your grade, 55. We go straight to F. Okay? Does everybody see how it's only ever going to be one of these bodies that gets run, but it's very interesting looking code. I believe that you could understand it if you stared at it long enough. So, any questions about this, what I just wrote? Why it models that little flowchart diagram, why it's gonna do the right thing? But the first thing we needed to test was greater than or equal to 90. If that's not true, we still didn't know the right answer, so we had to test again. Is it greater than or equal to 70 in that case? If so, it's a C, otherwise it's an F. Okay? So this looks kind of weird. There's a way to do it differently with elif, okay? Elif stands for else if. So it makes these things nicer sometimes. Here's kind of what it looks like. Oops, why do you think that was a typo but not the other? Whatever. So elif stands for else if. It's like an else and an if together at the same time. And I'll show you that by like copying and pasting what I did and making it work. So here's the idea. Here's what an if-elif else statement looks like. So you say if cond, if your condition is true, do one thing, indented of course, that's your first body, body 1. Then you can have as many elifs as you want. So elif, some other condition. This is like cond 1. This can be cond 2. This can be body 2 now. Do something if cond 2 is true instead. As many as you need. Another elif. This could be cond, I don't know, cond k. You have k different statements so far. And this is body k. Okay? And then finally, if you're done trying things, you can still have an else at the end. That's your, I don't know, body k plus 1. Yeah? So let me show you what's going to happen when these get run. Look at the else, the ifs, the elifs, and the elses. You have as many elifs in between as you'd like, but here's how it will run, okay? Let me try and say it in words. So the first thing that Python does when it notices this big thing, it reads it as a chunk. It's like only ever one body will get executed. The first thing it does is the first condition. It checks that condition. Hey, is cond1 true? If so, I will do the body. And then I'm done with the whole thing because I found somebody for which this works. Okay? Then it's done. If cond1 is false, it pretends that the rest of this was like an if statement. If, elif, else, all over again, kind of. Then it tries cond2. If that one's true, then it does body 2. Okay, so this is only ever tried, that's the key, only ever tried if cond1 fails, if it's false. Okay? We only ever move on if we found something was not true before. Okay? If cond2 is false, then it tries the next one, cond3. If that one's true, it runs its body, it's done with the whole thing. Down to this. If nobody else was true, it tries this cond_k condition. But if it happens to be true, it runs its body, and now it's done with the whole if, elif, else. And then finally, if every single condition was false, you can have an else statement. And that will always get run if nobody else got run. Okay, so this one runs. Emphasis on the only. Only gets run if every condition is false. Okay? So, any questions about this idea? Does it make a rough amount of sense in your mind? Because I'm going to convert the program that I just wrote to use if, elif, else instead. And it should make more sense. All right, but it's for trying possibilities. That's the whole point. Possibility 1, do this thing if it's true. Otherwise, try this one. Maybe this one's true, do that one. Otherwise, try this one. Maybe it's true, do that one. Otherwise, if nothing was true, okay, here's our false safe at the very end. Okay? That is what we do there. So, alternatively, using if, elif, else, here's what we could have done. Watch this. So this is kind of why it's called elif, because I'm going to do this. Boop. 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 There we go. That's essentially the answer. I think this is cleaner. This way is cleaner than this way. And these are equivalent. These are completely equivalent pieces of code. So here's kind of what happens. So these will output the same thing. Those are equivalent pieces of code. And here's how it works. If the grade is greater than or equal to 90, it prints an A. Read kind of elif as the word otherwise. Otherwise, if grade is greater than or equal to 70, print a C. And then else is just otherwise. Otherwise, if that wasn't even true, print an F. Those are your 3 options. Either this is true, we immediately print an A, or we try this one next. If that one's true, we do this. Finally, if nobody was true, we do this last one. Okay? That's if, elif, else. Trying a bunch of possibilities. So enter your grade, 95. They both print A, of course. Enter your grade, 75. They're both going to print C. So they are the same piece of code, essentially. 55, they both print F. Okay? If, elif, else's, try possibilities. Any questions about that? It might be easy to wrap your mind around this one right now, but I think you will grow to prefer this way. Okay? It definitely looks a lot cleaner if you're doing like A, B, C, D, and F together. That gets really ugly up here and quite nice down here. Okay, so I encourage you to try that. All right, are we ready to switch to turtle stuff? Because I will use if statements eventually again, but I might be saving that for your next assignment. All right, so if we're ready for turtles, let me show you how to draw stuff with color this time. Because the default color of the turtle's marks is black, we can make it prettier. And let me show you how to draw filled-in shapes with certain colors, because we made boxes, right? Why don't we make filled-in boxes with a certain color? That'll be cool. So let me show you this. So let's go to the documentation page just so that we have that in front of us. Python turtle. And it's all here. Color control. You got your color, your pen color, or your fill color. The first one I'm going to show you is pen color. You say turtle.pen color, and then you give it something. And that something is a string representing a color. Okay? So you can say like turtle.pen color brown. Things like that. Or if you know like the exact hex code of the color you want, you can give that too. It all will work. So this is what it looks like. You can change the color that is on the tip of the turtle's tail. Boop. You can control, like make it really blue. Things like that. And you just say this, turtle.pen color and a string that represents the color you want. So you can make it red and then move the turtle. That will make a red line. Boop. And then you can change the pen color to blue and move the turtle some more, and then it'll start making marks with a blue line. That'll be nice. So let me show that to you. Let's see here. Colored lines.py. So import turtle, turtle.shape, turtle of course. That is my preference. And then let's just draw some random stuff. So like turtle.pen color, make it red first. Turtle.forward 100. Turtle.left 90 or something. And then let's make the pen color blue and move them again. And so this will draw different things with different colors. Yay! So that's super fun already, right? We can draw pretty pictures with different colors, and there's a lot of different strings, like they all work, every color of the rainbow, and more. I'll show you a page that lists all the things that you could use later, but that's how you draw lines with color. You just say turtle.pen color. Does that make enough sense? So that's fun. Another thing you can do is actually fill in your shapes, which is also nice to have. So you can say, instead of pen color, you could say fill color. Let me show you that one. Where is the documentation? There it is. So fill color, turtle.fill color, works in the same way. You can say turtle.fill color violet. Things like that, or red or blue. And then, if you ever complete the shape, it will be filled in with that color. But you have to say some extra stuff. So let me show this to you. So let me make, I don't know, a sample program that draws something filled in. Filled shapes. .py, I guess. I can keep all this. That's not a big deal. Let's draw a square. Let's just get that there and ready. Let's alternate red and blue, because why not? That'll be cool. So that should give me a square if I do this. You don't need to turn at the end. That's unnecessary. So I have that. It's pretty and cool, but I can also set a fill color. Okay? So I can say, before I start drawing, I can say turtle.fill color of green. And you can tell what fill color you're using by the body of the turtle. I don't know if you can see it right now, but the default is black on black, so black lines and black fill. The turtle will change color. His body will change color to represent the fill color. So right now, his fill color is black, but we're not using it. But we can tell because his outline is in blue that that is the pen color. Okay? Whee! There we go. So now if I make it green, here's what happens. He knows he's green. He knows he wants to fill stuff, but we haven't told him to yet. Okay? There's an extra step. 2 extra steps, technically. So the turtle is not sure when he should start filling in things. You have to tell him to, like, okay, I'm going to start drawing a shape, and once I close it off, I would like you to fill that in blue, please. Something like that. The way you do it, the way you tell the turtle, hey, I want you to fill in the next shape that I draw, you say begin fill and end fill. You wrap that around what you're drawing. Okay? That is the goal. So let me go to that in the documentation page so that you see what it's going to say. But that's essentially the gist of it. Dun, dun, dun. Filling stuff. So begin fill and end fill. To be called before drawing a shape to be filled, and then to be called right after you call, you make some shape that you want filled. Okay? So here they are cheating using circle, not doing anything cool, but they're closing off the thing. And so between begin fill and end fill, you draw something that closes off itself, and then it will fill it. Okay? So that's all you have to do. So I just need to wrap this code with begin fill and end fill. That's all I need to say right here. Start filling, please. So I say turtle dot begin fill. And then we say we're done. Stop filling, maybe. So then I'll say turtle dot end fill. By wrapping this around what I drew, the turtle is remembering, okay, I'm ready when you close this off to fill it in. Oh yeah, that's all you have to do. Any questions about that? So just draw a shape and set your fill color and wrap around that drawing code the calls to begin fill and end fill. That's really it. That gives you a filled in thing. And it could be anything, whatever you draw. It doesn't matter, it'll fill it in for you. You can draw something weird looking. And as long as you close it off, as long as you close it off, it will be filled in with pretty colors. Whatever color you set the fill color to. Okay? Any questions about that? Because we're almost ready to do something kind of cool. Let me show it to you. The next to last thing that I want to tell you about today before I get into your programming assignment is randomness. Okay. Let's talk about how to do random things in Python. There's a library for that. It's called Random. That's useful. So let us look at that briefly. You can search for Python random if you'd like. This is the random library, and the one that we'll care about right now is Randint, random.randint, and you give it 2 numbers, and then it gives you back a random number between those 2 numbers. That's pretty sweet. So let's do that. Let's, I don't know, randomness.py, let's say. So import random, and then here's what you can do. You can say, like, you can get a number like this. You can call random.randint and give it 2 things. You can give it 1 and 10, and this will generate a random number between 1 and 10, and it puts it into n. Yeah, that's all. So if you print n, it'll be a random number between 1 and 10, because those were the bounds that I gave. And so I can repeatedly run this program, and because it's random, it'll print a different number each time. Let me show you that to you. So there's 2, there's 9, there's 8, there's 4. So it's perfectly random, and that's lovely, right? And we can tell it exactly what numbers we want it to randomly choose from. And that will help us draw our pretty pictures in a cool way. So don't forget to say import random, because that gives you the library, of course. But then the main thing that I care about you learning right now is the Randint function in that library. So you say import random. And then finally, the last thing that I want to show you before I introduce your assignment is this. Let's come full circle. Let me draw for you random squares. Okay? Let's draw a bunch of squares of random size and location. Won't that be fun? So like I want to do this kind of thing. Like here's my coordinate system. I draw a giant square over here, a tiny square over here, an even smaller square over here, a big square over here, kind of maybe overlapping. That's okay. Medium-sized square. That's what I'd like to do. Draw a square somewhere, randomly, with a random size and a random location. Okay? So let's think about what we need in order to do that. Well, I guess the first thing that we need to do is figure out where we're going to draw this square, right? We normally, at least the way I've shown you, we start drawing squares in the bottom left. So we need to get somewhere. We need to get to the place where we're going to start drawing that square, right? And we want it to be a random place. So that means we need to pick a random starting point. Definitely with a pen up, right? Don't want to be drawing lines between these coordinates. And then we just go there, right? So we need to pick a random starting x and starting y coordinate. Yeah? So we'll say stuff like this. Starting x equals random.randint. Like maybe between negative 300 and 300. And so I'll have a starting x. That'll be set to some random number, maybe like negative 200, something within this range. And then we'll also do a starting y, right? A starting y. That'll also be a random number. Maybe that becomes negative 100. And that will be the place that we start drawing our square. So we go there. We use turtle.goto to get to this place that we randomly generated. And then we start drawing a square of a random size. So we're going to need also that random size saved away. So let's pick a random size, maybe between 50 and 200 for each side length. And so then we'll just use another variable for that. So square side length. Length. Random Randint between 50 and 200, so maybe it's going to make a big one, like 150 or something. But this is all random, so that every new time we run the program, it does different things. Okay? So that's our game. So we're going to make 3 random variables and use them to control how we're drawing our square. Does that make sense? That'll be cool. And then we'll introduce color into it as well. So let's do this first. Let me steal from the code that I wrote just here that actually drew a square. So that'll help us. Random squares.py. And so let's not worry about the fill color right now. We'll do that again later. Let's not worry about the pen color right now. Let's just draw a square. And try and change this to what it needs to be. So I need my locations, my random starting locations, right? So starting x is this. Pick a random place to start on the x-axis and on the y-axis. And then, yeah, I need to import random because I'm trying to use that library. I need to do that too. So I have a place to start drawing this square, and I also need a size for the square. Square side length equals this. Okay? So these are all the variables that I need. They hold random numbers now within a range, the ranges that I gave. And now I just need to get there, right? The first thing I need to do is go to the random starting point. So turtle.goto, starting x, starting y. And then I want to start drawing, right? Draw a square there with the correct random size. So instead of moving forward by 100 each time to draw an exactly size 100 square, I'll move forward by whatever random side length I picked. So could be super small, could be super big, it'll be something. Okay? Does everyone see why this is going to make sense? There is one thing I forgot to do, though. Did anybody catch it? This is not going to be quite correct just yet. Should be very obvious when I run it. What did I not do? Yeah, when I'm teleporting the turtle, I need to pick him up. So that is important. Turtle.up. Then go wherever you need to go. Turtle.down again. That is right. So now I can just run this a million times. And look, I got a square there. It was big. And look, I got a square way over there. It was smaller. And this is very satisfying, right? Medium-sized square. Random starting point, random size. Does the code make sense to us? Because I want to add more things to it. Okay, so step 1, let's ask the user for which color to use. Let's make a filled-in square with a color that the user likes. That'll be nice. So like color to use, we'll get that from the user. Enter the color of the squares. I'll just say color. So eventually we're going to draw multiple squares. And this is perfect because input gives us a string. When we say turtle.penColor, or turtle.fillColor, it expects a string. We don't have to convert it at all. It's perfect. Just give it that color. Whatever the user typed, give it to fill color. Maybe it was the string pink. That's totally fine. String red, string blue. But this will set the fill color, right, to whatever the user passed along. That's perfect. And then I can draw my square. I want it to be filled in, though. So let's say turtle.beginFill and turtle.endFill after I'm done drawing that square. All right, so that's the full program. So the very first thing, before it draws anything, it will ask me to enter the color of that square. So I'll say pink, hit enter. So then it will set the fill color to pink and draw that square in a random spot. Sorry, it's off the page right now. But we can rerun it, use a different color, like blue, and there it draws another square. That was also off the page. Oh well. I have a small screen. Then we can draw a red square in a random location. Get that color first, and then, all right, that's where we're putting it. It's drawing it of a random size and a random location. How cool. Any questions about why this code's doing that? Because the very last thing that I'd like to do is not draw a single square of a random size and a random location. I'd like to draw 5 of them in different places, different random sizes, different random locations. However will I do that? So the nice way of doing this would be to loop. I haven't taught you how to loop in Python yet, so we are forced to copy and paste our code. Okay? So let me mark off a single square drawing. So all this code right here draws a random square of a random size and a random location, right? All this was just starter code that got us ready to do that. But if I duplicate this, it'll pick a new, right? It'll pick a new starting x, starting y, square side length, and draw another square. So this will draw a second square, yeah? Set these variables in a different way, because it's random, and then draw a square there. So this will draw 2. What color do we want? I don't know, green. So there's 1, and there's 2. Beautiful. And so if I want 5, I'll just copy this code 5 times. That's 2, there's 3, there's 4, there's 5. Because it's picking new values, using the same variable names, but putting new values into them because it's random. And then it goes to that starting point that we randomly picked and draws that square of that random side length. How cool is that? So, yeah, that's our full program. Pick the fill color at the front of, at the start, and then draw 5 times random squares. No, yellow this time. And so we have just fancy abstract art at this point. Squares can overlap, that's not a problem, it's random. But we are randomly drawing them. How cool. What color have I not picked yet? Orange. There it goes. How fun. So yeah, that's the code. Any questions about it? Ask the user for the color, set it, and then repeatedly pick random spots and sizes, go there, draw a square. Remembering to use begin fill and end fill. We comfortable with that? I'm giving you the code anyway, so don't worry too much. But that's what we would like to do. That's what we did. We moved our turtle to that starting location, and we picked a side length and drew a square like that. So if we're comfortable with that, I am ready to show you your programming assignment. You're going to have to combine randomness, drawing things with filled colors, and then conditionals. Okay? It's based off of that a very weird YouTube video. So let's go there. Programming assignment 6, due week 12. So here it is. Here's what I'd like you to do. So I drew random squares. It's your turn to draw random triangles. Okay? That is the goal. What I want you to do is write a Python program that uses turtle and random to draw 10 triangles of random size and location. You can do equilateral triangles like I showed in class. That's totally fine. But if you'd like a challenge, do a different kind of triangle. That's totally okay as well. Your requirements. You must ask the user what color to use as the fill color for those 10 triangles, just like I was doing for the squares. Okay? And then you got to set the fill color to that color, except when the user asks you to use green. Okay? Because green is apparently not a creative color. If the user asks you to use the color green, then you must not use it. You better disobey the user. Pick a different color, something other than green. Okay? You can hard code it like, okay, it's going to be pink instead of green or something like that. But you cannot use green. You cannot let the user pick a color of green. So that's going to involve an if statement. You see that? You better check before you set the fill color. So yeah, just change it to be something other than green in that case and draw 10 triangles with that color, random size, random location. Does that make sense? That's what I want. And that shouldn't be too bad basing what you do off of the program that I just wrote today. Okay? So it's going to be a lot of duplication, and I guess that's kind of the goal. I want you to notice how painful it is to copy and paste this, because that'll really set us up for learning about loops later. Okay? So I think if there are no more questions, that is all I have for us. So feel free to get started on this assignment in the remaining time.